All right, hi year 12s, this is Mr. Lim here again, and this is our first video in equilibrium, and we're just going to go through rates of reaction revision again, just to make sure that you remember it all from last year. Okay, so if you want to have more detailed explanation, make sure you go watch those videos from last year. All right, so we're just going to quickly go through and try and remember all of the requirements for a successful collision. Okay, we're going to remember, and we're going to really think about why we have to use the word frequent, what changes can change a reaction rate, and then how each of those changes is linked to the collision theory. Okay, so that's what we're going to do. Okay, so let's have a look. So collision theory, we remember that what you need for a successful collision is a physical collision, so the particles must collide. They must have sufficient energy. What that means is that they need to be moving fast enough, right, when they collide with each other so that they can actually break the bonds that they need to. If they're not moving fast enough, then they're just going to bounce off each other and it's going to be an unsuccessful collision. Okay, this sufficient energy is also known as activation energy. Okay, so hopefully we remember that, and we also remember how to draw that on a graph. Okay, and then the correct orientation. So the orientation is just the way that they hit each other. Okay, so perhaps this reaction here needs those two particles to react just like that, but if they somehow collide in this manner, maybe the reaction won't occur. Okay, so if they move that way and they move that way, and then this might be a unsuccessful collision, even if it has sufficient energy because they're in the wrong orientation. But this one will be a successful collision because they're in the correct orientation. Okay, so just those three things are required for a successful collision. Right. So whenever we talk about rates of reaction, it's how many reactions are occurring over time. Okay, so it's really important that whenever we're dealing with rates of reaction, it's something over time. So if you are referring to something over time, you must refer to that time when referring to rates of reactions and collisions. So instead of saying just the number of collisions has increased, you would have to say the frequency of collisions has increased, or the number of collisions per unit time. But I like the idea of frequency, it's a bit better. Okay, but it's also not sufficient to just say, oh, okay, then the frequency of successful collisions has increased without saying that leads to an increase in the rate of reaction. Okay, because if you just say the frequency of successful collisions increases, you're not actually don't link it to the rate of reaction, you can also lose some mark. So what we're going to be going through a lot this year is just about vocabulary and making sure we use the right vocabulary when we're answering questions. So use the word frequency of collisions and frequency of successful collisions, and then also using the words linking that frequency of successful collisions to the rates of reactions. Okay. What kinds of things can change rates of reaction? So we've got the 5 different things: concentration, or if it's a gas, it's partial pressure, temperature, volume, catalyst, and surface area to volume ratio. Those are the 5 things. Hopefully you remember that from last year. Okay. How do each of these changes affect collision theory? So concentration is going to affect frequency of collisions. Okay, so remember, you have collisions, sufficient energy, and correct orientation. So concentration just increases the frequency or decreases the frequency of collisions. That's it. It doesn't affect the other two. Temperature will affect the proportion, and this is another vocabulary thing, the proportion of particles with sufficient energy. Okay, so that could go up or down depending if the temperature goes up or down, and the frequency of collisions. And I don't know why there's an R there. So the frequency of collisions, because if you're moving faster, you're going to collide with each other more often, or if you're moving slower, you're going to collide with each other less often, right? The volume, we're going to link that to the frequency of collisions, because if you think about it, if you change the volume, you change the space that the particles are in, which means that they have less space to move or more space to move, and therefore they're going to collide more or less often because they have of the change in the amount of space that they have to move. Okay, a catalyst can change the proportion of particles with sufficient energy. Okay, now if we remember catalysts, what do they do? And this is again all about vocabulary. What do they do? Catalysts provide an alternative reaction pathway with a lower activation energy. Okay, so remember, if you have a catalyst, you're going to increase the proportion of particles with sufficient energy because you've lowered the activation energy by providing an alternative reaction pathway. And so if you've got a higher proportion of particles, you're going to have a higher frequency of successful collisions per unit time, right? And it can also affect the correct orientation. Okay, this is more of a biological enzyme catalyst thing where they grab onto particles and make them be close in certain ways so that they react faster. But the idea is that they are there to improve the orientation. And then finally, the surface area to volume ratio, right? That's how much is exposed to the surface. So again, the surface area to volume ratio, surface area to volume ratio is about the amount of particles exposed, which leads to an amount of particles exposed to the other reactants, which leads to a change in the frequency of collisions. Okay, so if there's more particles exposed, there are more frequent successful collisions, or more frequent collisions leading to more frequent successful collisions, leading to a higher reaction rate, and vice versa for a lower surface area to volume ratio. Okay, so that's the revision for rates of reactions. Go watch the old videos if you don't remember. Adios.